Hello everyone, good morning, good afternoon, good evening, depends on when you're watching this lecture. Welcome back. It's going to be lecture 2, chapter 2 and chapter 3. I feel like we'll be able to cover both of these, and once again, both of these are going to be from the book about C. Unix, like as I told you last time, what I said last time still stands up till today. Without further ado, let's get into it. The C language. These are some of the things that the book talks about. Actually, these are fundamentals, basic. By the end of the course, or maybe if you've had another language in the past, these will be just refreshers. What is syntax? Syntax, as a word suggest, it is syntax itself, but it's actually the language. It's the language of the what the compiler understand. So syntax has keywords in it. Syntax has constant, has the semantics of all the languages. So the English language you're speaking, vowels, constants. Well, I shouldn't really compare. That's not a good comparison. But syntax are all the main words, the things that you type in that tell the compiler what you're looking for, right? Because you need a medium to communicate. Hopefully that's clear. Um, One of the main thing, the first thing that we start off with is comments. What are comments? Comments actually help beautify or make your program much more readable. Whenever we look at these examples, let me just go to round 9. Come on. I'm gonna open up the C compiler online, and one of the first things you're gonna see there is comments. Um, there it is, right? This is the first comment. So the way you write these comments are by these two slashes right here. Very easy. That's one way. The other way is the slash and an asterisk. But if I haven't mentioned this before, see everything after that, the color changes because that's the beginning of the comment and that is the end of the comment. You see the color change? Anything in between is ignored by the. So any comment, program doesn't care about it. Anything after two slashes or anything in between the slash and asterisk, it doesn't really care. Um, it doesn't get compiled, it just gets ignored. But that does not mean that you do not have any comments. Comments are very essential to your program, and you might hear me say this again and again as years down the line when someone comes and looks at a code, might be your code, might be someone else's code. If it's someone else's code, having these comments is a key because comments actually tell the other person, the reader, the troubleshooter of your program, or anyone that's going to come years down the line, what the program is doing, or what the module, or the method, or the function is about to do. So it helps it explain things in a very simple form. And it's the key. I look at comments. When I do code reviews, I make sure that if it's something complicated or something that's going to live on for a long time, I encourage people to write comments. Keywords are essential special words in the C language that have a special meaning. The while loop, the if, int, after int there's supposed to be a comma, double. So basically all the looping, all the case, switch, enum, void, int, double, float, character, all of these are keywords. That's how you know the type. Okay, so basically whatever you write to denote a type in C, that's a keyword identifier. That is simply, how do I say it? Let's say for example if you have int I is the identifier. Now as you write complicated programs, you're gonna have to give a meaningful name to your identifier. Let's say if it's the name of the car, you say string name underscore of underscore the underscore car, right? Because it's gonna make your life a lot easier if you have meaningful identifiers. So identifier is simply what you identify the. So it's typically after the keyword. Um, I should say after the type. So keywords have different categories, right? So some of them are types, such as int, double. Um, so int, after that comes the identifier. Hopefully this is straightforward. I don't have too many examples of this, the basic building blocks, but once you write your first program, you deal with it. This is going to be second nature to you. Next up is constants. What are constants? Const int I equal to 0. You guys know already int I equals to 0, right? So I am declaring an integer. The identifier is I. That's the name of the integer. And I'm assigning it to 0. Now, one thing, C should be lowercase. That's a typo. PowerPoint corrected itself, thinking that it's doing me a favor, but not in this case. I think I just forgot to make it lowercase. Because typically, when I'm typing something and it forces me to have an uppercase, I'll change it. I'll change it once, twice, maybe this time I give up. Nonetheless, so if you put the keyword const in front of your variable, it becomes a constant. Now, further down in the program, if you try to change int I, it's going to throw an exception. It's going to give you some sort. No, it's not really an exception. It'll throw an error. It'll say you cannot change the value. So that's what a constant is. Simply a variable that you've defined it to be constant. And you'll see, later on, you'll see examples and reasons and cases where you should have it a constant because in your program you decide that this integer or double or whatever the variable is should not be changed by anybody. Um, so you pass it to something or pass it to a function or someone else comes write code and tries to change it, well, the compiler is going to throw an error. Now, if that programmer wants to take the const away from it, he better have a damn good reason because you are changing the fundamental of the program. Next up is the precedence of operator. That's operators, plus, minus, subtract, divide, multiply, etc. Those are all operators. They operate on variables. The precedence, how do you know what the precedence is? By default, the precedence of operator is from left and right, left to right. Now, in C, each type of operator has a precedence. Multiply has a high precedence and plus or minus. Now, this example is the same one I pulled out of the book. It was an interesting one. I liked it. It helps me show you guys how to simply understand it. So, int I equals to 1 plus 2 times 3. Now, if you run this, what do you think is going to happen? If you guys are thinking it's going to be 3 times 3, you're wrong. It's actually going to do 2 times 3, which is 6 first, and then add 1 to it, because multiply has a higher precedence. Plus and minus, they both have same precedence. Now, you might be thinking, oh man, I got to remember this precedence in order to make my life easier. No, you don't really have to. What you can really do is you can use parentheses to make your life a lot easier. So if you have equals 1 plus 2 times 3, right? So what do you think is going to happen? If you think it's 3 times 3, 9, no, that's wrong. What it's actually going to do is multiply has a higher precedence, so it's going to, it's going to do 3 times 2, which is 6, plus 1. So in this case, it went right to left. Well, that's because multiply had a higher precedence. And like I said before, plus and minus, they have the same precedence. There's no one is higher or lower. But if you really want to do, you have to remember the precedence you can use parentheses. So this way what's going to happen is it's going to do 1 plus 2, 3, and then 3 times 3. And you could even do this. So let's say if you had 1 plus 2 after that, you could do something like this. Hopefully this is clear. So I put parentheses around what I would like to see the result as. First it's going to do 1 plus 1. It's going to go left to right. 1 plus 1 is 3, and then it's going to go here. 3 times 3 is 9, right? So then these parentheses come into action. Now you've got 9 plus, this in parentheses is going to add that. So 9 plus 3, right, 12. So it's going to come up with 12. So try to use these parentheses. That should make your life a lot easier. Okay, so next thing I'm going to talk about is the pre-increment operator and the post-increment operator. Yeah, the name sounds bigger than what it is really. So let's say, for example, you've got an int I that's declared already, and you want to increment that by once. All that means is you want to add 1 to it. So what you really want to do is I equals I plus 1. There is a shorthand method of saying I equals I plus 1. You can either do I plus plus or plus plus I. But from the impact perspective and practically it's slightly different. I plus plus is post increment and plus plus I is pre increment. Now without going into a further lengthy discussion, let me show you an example of how really this works. So here you've got an example. You've got int I, and I'm going to say printf I plus plus, and then the next thing will be plus plus I. I ran it already so you're able to see. First you get 1, then you get 3. I plus plus is actually post increment. So what's going to happen, it's going to output I and then increment it. Oh, I should really do it. I plus plus. What I really wanted to do was this. That's a better example. Well, no, I think I and J. Hey, let's call it J equals 1. Now, yeah, that's a better example. That's what I was really trying to show you is the I plus plus is post increment, so it's going to output first and then add 1 to I. So that's why the first time you see 1. And then J, it's pre-increment, so it's going to say J equals J plus 1, which is 2, and then it's going to output it. So that's practically how you understand the difference between the two. Now let's go on to chapter 3 here. Chapter 3 is another discussion about the basics. The first thing we're going to go into is the different data types, okay? We talked about keyword, we talked about identifiers, we talked about comments, but data type is also part of the syntax of the program. Int, float, double, short, unsigned int, long double. Honestly, you don't, and char, character, right? Those are char. So you have to remember each and every one of those types, how they work, examples, etc. The most commonly used and for the purpose of this class and most likely in the future too, you'll be confined to int, float, doubles. Short and long double, I mean they will come if you get a super lengthy number, yeah, maybe long double, you can go with that. But for the most part, in examples, I'm going to focus on int, float, and doubles. And then characters are A. That's what else do I want to cover here? Int, floating types we covered. In the book, it talks about type def. Now, what type def is is you rename something. So if you do type def char to uppercase, type def int to inches of int, what I'm really trying to say is, let's do this. So I do type int, let's call it integer. Now, if I have this in here, voila, it's gonna work because what you did was, hey, you say, hey, the ints, I'm gonna call them integer. Um, why are you going to do? You can do it for any type basically. You can do it for char, double, float, whatever you want. I mean, obviously you're gonna give it different names, right? So double you call double or whatever you feel is convenient for your program. But you are gonna this type def comes in handy when you've got a long program, a big program, multiple classes, files, etc. And you some of these names you want to distinguish. You want to differentiate or give something else a different name. Um, that's when this comes in handy. Then there is also the size of operator, which tells you the size of an object. Um, oh, something's going on with my computer. Okay, it's back on. So while we're in the topic of characters, let me go ahead and mention to you about two methods. One is get character, the other one is put character. Now, I mean, obviously, when I say this, it's quite obvious what each one of them is going to do. Get character is going to get taken or get a character from the user or from the console, and then print. I'm sorry, and then put char is going to output the character. This is a simple example that I'm going to show you for the get char and put char. So let me go ahead and try that. Um, enter a random character. Let's say enter in C. The entered character is C. So the first line, where you said enter any random character, the get char comes into play. So it'll read in from the console and then store it into this character. It's an integer. The actual representation behind the scenes for characters is a number or an integer, and you can look up, what the corresponding numbers are for each character. So, because underneath the hood, it's all zeros and ones and numbers. But you have to memorize it. You just have to know this as a theory. You're not going to be get tested or ever have to find out what A uh, in the background is or Z is in the background, etc. Okay, so and then when you do printf, then you put char, you output that character onto the screen. And then the same thing, right? It converts it from that number to the character. Um, this example is simple enough. Now the next thing I wanted to cover is there is a math library, include math.h. You will have to do this. Now, this math library is great because it comes in with a whole bunch of built-in methods. Um, some of the methods are these, not all of them. You can look up the all of them. I mean, book also mentions it, but these are some of them. There is the absolute value of x, cosine, sine, tangent, etc. Um, Besides this, there is also power of x, square root of x, exponential of x. So so you don't have to write a function that does this calculation for you. Having the presence of these libraries is supposed to make your life a whole lot easier. Um, and let me walk through a few examples of math.h. So the methods that I'm going to cover is the ceiling, the floor, and the power. Ceiling, if you have 11 point something, it's going to take in, ceiling means the top, floor means the bottom. So the way to explain this is let's focus on the ceiling of 3.3. The word ceiling means the top. So the top of 3.3, it rounds, it goes to above that number, more than that number. If you have 2.3, it's going to say 3. 3.3, 4. 3.5, 4 again. 4 point something is going to be 5. So it takes the higher end. And then floor, anything after the decimal point, it'll ignore it and it'll take the first 3.0. So 2 point whatever is 2. Like so 1.7 is 1.0. So it should be straightforward. Floor and ceiling method. Might get tested on this in your exam. And the power of function, power takes in two parameters, x and y. So in this case, I gave it 3.3 and 1.1. 3.3 raised to the power of 1.1 is equal to 3.7. Now, like I said, it makes it a whole lot easier. You don't have to memorize all the methods in there, but over time, as and when you try out these examples, you're gonna get to realize that, hey, I can use this library for this method, etc. And then that's gonna make writing a program easier, and you can also accomplish it with less lines of code. Okay, so the last topic I want to cover is it has to do with cast and conversion. Um, and casting something or converting something, they're kind of similar. There are two types of it. One is implicit conversion, explicit conversion, and all of these they have to do with data types: int, float, double, character. These are examples of data types that can be converted from one type to the other. Implicit is one that the compiler does it for you. The explicit is where in parentheses you tell it the exact type that you want to convert it to, and then you do it. So you're being very explicit, very forthcoming with this type of conversion. I can illustrate this via two example. Now the conversion is happening between int and a double. So I've got a double value 4150.12, and then I convert that to the integer. Let me see where's the issue? Create double number 20. Missing a parenthesis. So now you notice that in the integer, the after the decimal point was ignored because the compiler did this conversion for you. But keep in mind there is some data loss, right? So if you're going from higher to lower data type, from a double to integer, there is going to be some data loss. Now let me go ahead and show another example. In here, I've got a number and a double. And when you run this, 35 goes to 35.00. It's higher precision, there is no data loss. So you have to be careful. And see the difference between this one and the previous one is, in parentheses, I told it explicitly that this is what I wish to do. With the number is I want to convert the number to a double. And the compiler does it. You can call this casting as well. You'll see many more examples of this as you go along. But this is a straightforward example. Yeah, and give it a try. These are fun sorts of examples to play with, conversions, and see if you come back with any questions or concerns. So that's it for this lecture. See you guys next time.